Hello, my name is Houssem Saidi from the University of Toulouse. In this video I'm going to present our work on the HoloBar, which is a novel approach with interaction with multi-level menus. So executing commands in head-mounted displays usually requires activating a menu, which is then displayed in mid-air in the field of view of the head-mounted display. To interact with this menu, the user has to perform mid-air gestures to select and validate items. Today, most menus in head-mounted displays use mid-air gestures to execute this process. So there are two major issues with this approach. First, displaying menus in an already narrow field of view occludes the displayed content and limits the size of the menu that can be displayed. Second, mid-air gestures are usually rather difficult to perform accurately 100% of the time. A potential alternative to this approach would be combining smartphones and head-mounted displays to improve this process. This approach presents several advantages, such as extending the head-mounted display's limited field of view. It also exploits the accuracy of the smartphone's tactile input, and perhaps more importantly, it augments the number of degrees of freedom. This usually means a bigger interaction vocabulary. This approach has been used for several use cases. However, these use cases focus mainly on ad hoc tasks, so usually navigation or 3D exploration. The work presented in this video explores this approach to ease interaction with multi-level menus through what we call the HoloBar. So the HoloBar offers a multi-level menu based on 4 grounding principles. The first principle is rapid activation of the menu anytime the user needs it. So to activate the HoloBar, the user brings the smartphone beneath the field of view and enters what we call the activation zone. As soon as the smartphone is detected inside this zone, the HoloBar is displayed. The top-level menu is displayed as an unobtrusive menu bar on the head-mounted display, while the second-level menu is displayed on the smartphone. Placing the second-level menu on the smartphone limits the head-mounted display's view occlusion and, more importantly, allows for a preview of the second-level items. To select top-level menu items, the user moves the smartphone horizontally under the HoloBar. From the user's perspective, he or she must visually place the smartphone under the item to select. This corresponds to the user aligning his head, the smartphone, and the target item. Moving the smartphone under the HoloBar implicitly selects the top-level item and displays a preview of the second-level item on the smartphone. We conducted 2 studies to evaluate the HoloBar. The first one tries to identify the smallest possible activation distance for the HoloBar, and the second one investigates the performance of the HoloBar for command execution compared to 2 other menus. As we wanted to identify the smallest possible activation zone, we evaluated 3 activation distances. A small one, which equals an angular size of 10 degrees, medium one equaling 20 degrees, and a large one, 30 degrees. We found that an activation zone of 20 degrees was the smallest activation distance that would grant good performances. Then we investigated the performance of the HoloBar for command execution compared to 2 other menus, so HoloLens-like menu and the hybrid menu, combining the interaction of the HoloLens menu with the layout of the HoloBar. This allowed us to compare the HoloBar in terms of menu distribution, so fully displayed on the HoloLens or split between the HoloLens and the smartphone, and menu layout, so either linear layout or grid layout. Results showed that the HoloBar ensured not only a quicker overall completion time, but also outperformed the other approaches in each step of the command execution process: the menu activation, top-level item selection, second-level item selection, and final validation. So this concludes this video, in which we briefly presented the HoloBar, a novel approach for command execution. We saw that the HoloBar offers a multi-level menu that can be rapidly activated anytime without occluding content and without disrupting the user's activity. This work also determined the most suitable activation distance for the HoloBar and compared its performances to 2 other menus. We found that it was at least 29% quicker for command access while maintaining a 99.4% success rate.